Today, we will continue the same chapter, periodic table, and today's topic is first, second, and third ionization energy. So, what do we think about ionization energy? And we have read about it in the previous classes, right? So, an element, gaseous, free state, it requires some amount of energy to be pulled off the last electron, and it will be M plus gaseous, that is an unipositive cation. From a neutral atom, removing one electron, it will become an unipositive cation, and the required amount of energy is known as first ionization energy. So now, the same thing, the same unipositive cation we are taking, and then we are giving it its required amount of energy to pull off its second electron. So the first species, unipositive cation, will become bipositive cation, losing its true electrons. In the next step, we are taking that bipositive cation and giving its required amount of energy, and its loses electron, that is third electron, is being pulled off. Losing its third electron, the bipositive cation will become a tripositive cation, gaseous state. We will move to an example. Example, aluminium. Aluminium has its atomic number 13. Electronic configuration of aluminium is K2L8, total is 10, and then M3, right? The last shell is M, and the loosest electron, that is the outermost shell electron, last shell electron. Three numbers of electrons are there. So, as we move from nucleus towards the last shell, K the first one, L the second one, M the third one, last shell M, the last electron, that is the outermost shell electron, being far away from the nucleus, there will be lesser pull, right? So, as the distance from the nucleus is increasing, the attraction force being inversely vary with 1 by r square, inversely vary with r square, r being greater, F will be lesser. So lesser pull for the last electron, so greater amount of energy, less amount of energy to be needed to pull it off. So aluminium being given its first ionization energy, which will become Al plus gaseous, and then Al plus gaseous is given to its second ionization energy, required amount of energy. It will become a bipositive aluminium 2 plus, gaseous cation, and then taking this cation Al3 plus gaseous, giving amount of energy, required amount of energy, it will become a tripositive gaseous cation. So now, what will be the amount of energy it should be given? Aluminium being first a neutral species, an atom, there was electron density around the nucleus. Atomic number 13, aluminium has its proton number 13 as well as electron number 13. Now, 13 protons were pulling 13 electrons, right? So, here, per electron pull was greater, good enough, okay? So, here the amount of energy was given, and it became a cation, Al plus, Now it has 13 protons. Because protons are in the nucleus and proton will not be pulled off, electron become one less. Minus 1 is being 12, right? So now 13 electrons are pulling 13 protons are pulling 12 electrons. So it will be a greater pull, right? So the electron density will come closer to the nucleus and the atomic size will reduce. Now the electron which was in the valence shell, the second electron at the M shell, will come closer, right? From the previous one, it will come closer to the nucleus. So more tightly bound, force will be higher, more tightly bound than the last electron. So the greater amount of energy is needed to remove that. So if we give IE2, Al will be Al2 plus and proton number will be 13. It will remain same, but the electron number will be 11. So 13 protons are pulling 11 electrons. So here the per electron pull will be greater than the previous one. Size will again reduce. Okay. So as we move from aluminium to Al2 plus to Al3 plus, Al2 plus, size is reducing. So the electron being much closer. So the nuclear pool is being greater enough, that the greatest, that is more from the last one. And if we give IE3, that is the third ionization energy, Al will be at 3 plus, right? So required amount of energy will be greater from the previous one. So the trends in ionization energy will be IV1 less than IE2 less than IE3. IE3 will be of maximum value and IE1 will be of minimum value. So this trend will follow if we have a plot with energy, and here IE1, IE2 and then IE3. IE1 will be of least value, then IE2 will be greater and IE3 will be greatest. The value will move just like this. Okay. It will be greater, greater and greater. So we have read about the whole thing, the trends, okay, as we move along from unipositive to bipositive to tripositive. The amount of energy requirement will be greater to remove the last electron because the size is being decreasing. So the electron being more closer to the nucleus, it will be more tightly bound. So the train will be just like this, IE1 less than IE2 less than IE3. To get our next video, that will be on electron affinity, please subscribe our channel. Thank you.